He likes multiple birth problems. And it's different than a card problem, because in a card problem, when you're dealing hands to people sitting around the table, once the card's been taken out of the deck, it can't be used again. So you get an automatic decreasing of what's available. The same thing is not true of tossing coins or having children. If the first child in the family is a girl, does that mean that the second child in the family has to be a boy because that's the leftover? Absolutely not. If that were the case, then my father should have quit after having my older sister and myself. But he had 5 more children, excuse me. And they were all females. So I am the only boy, which explains why I'm weird. Okay? I got all the math genes. None of my sisters got any math genes. But I got all the math genes. And yeah, I did their homework for them a lot of the time when they were in high school. And they paid me handsomely for that. Okay, so how do we start with this problem? 5 children. Child 1, child 2, child 3, child 4, child 5. Excluding multiple births. I don't think that needs to be in there, but it's in the workbook pages. Even if the mother does have twins, the twins don't come out of the birth canal at the same time. And the doctor doesn't pull them out if it is a cesarean at the same time. So one of them is always out a little bit before the other one happens to be. So yeah, but they think that twins makes it a different situation, and that's not more than one child. It is more than one child. So 5 children, and what do you specifically have to have? 4 girls, 4 boys, and 1 girl, in any order. Now here's the problem. Drawing the lines in this case doesn't really do a whole awful lot like the card problems did, because we don't have a decreasing element. So we have to ask our questions a little bit differently. You're going to have to put 4 boys on those blanks somehow. And you're going to have to put 1 girl on the blank somehow. Would it be easier to answer the question, where are the 4 boys positioned? Or the question, where is the 1 girl positioned? Because there's only 1 girl, right? So where, I'm not attacking the boys directly. I'm going to attack the girl because there's fewer of her. I'm not picking on her, okay? There's fewer of them that have to track. And if you know where the girls could go, it automatically takes care of where the boys could go. So where could that 1 girl be in the birth order? And I'll give you a hint. It answers the same kind of question we've been asking before. Could the girl be the oldest child? Could the girl be the baby of the family? Could she be the middle sibling? So where could she be?
Anywhere.
Anywhere is not a number.
Any of 5 places.
Thank you, there we go. But I'm picking on, sorry about that, okay? Any of 5 places. See, I need a number. Do we really care if the girl is over here? It's just as good if she's over here. So literally any of 5 places, and that tells me everything that I need to know about the numerator. I don't have the typical fill in the blank like I have with card problems. Now I have to figure out, what about the birth order altogether? What are the chances of having a child at all? What are the possible outcomes? Boy or girl, right? So we have 2 possible outcomes for the first child. We have 2 possible outcomes for the second child, which is different than all the card problems we did because the birth order regenerates. It's back into, it could be either a boy or a girl. Previous experience doesn't mean it's the same thing. Mom may say, I don't want another boy. But you ain't got much choice, okay? Unless you do some in vitro type of stuff like that. We're not going there, okay? So we got these things. So there's actually 32 ways in which a family of 5 children could be built or constructed or composed. Of those 32 ways, how many of them meet your needs of having 4 boys and 1 girl? 5. Okay, so I have 5 acceptable outcomes out of the 32 possible ways that could happen.